Hello guys, welcome back to a new video from Smart Interviews. Today we'll be looking at the problems from Codechef Starters 140. I'm Sahil and let's begin. Let us look at our first problem today, yoga class. I'll quickly read the problem statement. On the occasion of Yoga Day, the only yoga instructor in Chef Land, Chef has received numerous queries. Chef has managed to free up N hours. There are two types of sessions the chef offers. So basically in the input we are given three things, N, X and Y. N is the number of hours chef has in which he can teach yoga. N is the amount of hours chef has in which he can teach yoga. Now what are X and Y? So chef takes two types of sessions. Basically chef teaches yoga by taking two types of sessions, type 1 and type 2. For type 1 session, chef charges X amount of rupees per hour. For type 1 session, he charges X amount of rupees per hour. And for type 2 session, which lasts for 2 hours, he charges Y amount of rupees per 2 hours. Right, so these are the values of X and Y. X type 1 session lasts 1 hour and he charges X amount of rupees. Type 2 session lasts 2 hours for which he charges Y amount of rupees. And we have to find what is the maximum amount of money chef can make in N hours. What is the maximum amount of money chef can make in N hours? So let me look at the problem sample input as well. So 4, 5, 7. So chef has 4 hours. And this is the value of X and Y. Now let us suppose chef takes only type 1 sessions. That means he can make 20 rupees. He makes 20 rupees if he takes only type 1 sessions. What if he takes type 2 sessions? So he can take 2 type 2 sessions, right? There are 4 hours, 4 by 2. He can take 2 type 2 sessions and each type 2 session costs 7 rupees. So 14. Among this, the maximum is 20. So we'll output 20 as our answer. So this was the question. I hope everyone is clear with the question. Now let's proceed with the logic of how to solve this problem. The logic for this is pretty simple as well. We'll just take both the scenarios. First, we'll see how much amount of money chef makes if he takes only type 1 sessions. And next, we'll take the other case, that how much amount of money chef can make if he tries to take only type 2 sessions. And among these, we'll output the one whichever is the maximum. That's a simple logic for that. So if we look at the third example, 5, 2 and 6, chef has 5 hours and X value is 2 and Y value is 6. So again we'll start with the first case. Suppose chef takes only type 1 sessions which cost 2 rupees each. So chef can make 10 rupees at the end of 5 hours. What if it tries to take only type 2 sessions? So there are 5 hours, right? So chef can take at most 2 type 2 sessions. Chef can take at most 2 type 2 sessions and each of them will cost 6 rupees. So he makes 12 rupees. But there is still 1 hour left, right? Chef's taking 2 types of sessions, which are 2 hours each. So total 4 hours, but N is 5, so 1 hour is left. And in that 1 hour, chef will take type 1 session. Will not waste any hours. Chef will take type 2 session. So type 1 session, and this will be 2 rupees. So in total, chef is making 14 rupees in the second scenario. And since 14 is greater, we'll output the answer as 14. So this is the logic, guys. Let's proceed with the code. Let's look at the input format. We are given T, N, X, and Y. I'll quickly take these values as input as well. Now, as per my explanation, I will consider for the answer, I will consider both the cases. First case is he will take only type 1 session, that is for n session he will take only type 1 session. So n into x will be the amount of money if it takes one type 1 session. Now what about the other case if it takes type 2 sessions, right? So first of all, how many type 2 sessions can it take given that he has n hours? He can take n by 2 type 2 sessions. He can take n by 2 type 2 sessions, and each type 2 session cost y rupees. Now he may have hours left over. He may have some hours left over, and how do we find out if he has any hours left over? We'll simply do n mod 2, and in this example he can only take type 1 session, right? And among this will output whichever is the maximum. If we're getting the wrong answer for the third case, here I have to multiply with x, right? He takes x amount of rupees for type 1 session. Let's try to submit this. Yes, it's working. Finally, let's move on to the next problem. Make permutation is our next problem. Let me read the problem statement. Chef has an array A of size n. He wants to make a permutation using this array. Find whether there exists an array B consisting of n non-negative integers such that an array C can be constructed where C of I equals to A and Bi. So in the input we are given n, which will be the size of the array, and then we will be given n elements. So we are given an size of the array and array elements. So what do we have to do with this? So with this we have to check if another array C can be constructed, and we have to check whether another array C can be constructed such that C is a permutation of n. C is a permutation of n. Now let us go one by one here. What do you mean by permutation? Permutation is nothing but, suppose if n equals to 5, my array should have all the numbers between 1 to 5. It doesn't matter the order. The order doesn't matter, but it is the size of the array should be 5 and it should have all the elements between 1 to 5. That is what we call a permutation of array. So this is a permutation. This is as well a permutation, so there can be many permutations. So this is what we mean by permutation. Now we have to, given an array C, we have to check whether we can form an array C such that we can create an array C such that array C is a permutation of A n. Now how do we create this array C? For this we have to construct another array B, and suppose Bi, these are the elements of array B. So let me write this a little neatly. Suppose these are the elements given to us. In the input, and we have to check if there exists any other array B. So B array should be of size 10, and suppose these are the elements of the array B that we came up with. So B1, B2, B3 and so on, Bn. Right, and when we add these elements of A and B, so this should be, you should add this element and form C1, add these two elements, form C2, add these elements, form C3. So whatever array C that we have, whatever array C that we generated should be a permutation of n. We have to check if this is possible or not. If this is possible, then we have to output yes. If this is not possible, then we have to output no. So this is the problem statement, guys. I hope the question is clear to everyone. Now let's proceed with how can we solve this problem. Now to understand the logic for this question, let us look at the first sample input. So in the sample input, this is the array which is given to us. So n is 5 and 4, 1, 3, 2, 1 are the elements given to it. Now in our desired array C, it should have all the elements from 1 to 5, right? Then only it can be considered as a permutation of n. So we'll try to construct that itself. 4. Now 4 is not present in our array currently. So what I'll do is I'll just add 0 and I'll take 4 here. Right? No, so my array C currently has 4. 1 is also not present in my array C currently. So I'll just add 0 here. So this is supposed to be my B array and this is A array. In my B array, my next element as well, I will take 0 and my element will be 1. So 1 is as well present. So next element is 3. 3 is also not present in my array C currently. So I'll take my third element in array B as 3 itself, as 0 itself, and my output will be 3. And same case goes for fourth element, this. Now what about the fifth element? Now how many elements do I have? 1, 2, 3, 4, right? So I need what? 5. I need another 5. And what element do I have currently? 1. So if I add 0, I'll just get 1 here. 1 is already present in my array C. So this can't be a valid permutation. So I need 5, right? So what element should I add here to get 5? 4. If I take 4 here, this sum, when I do the sum, it will be 5. So in my array C has all the elements in range 1 to 5. So I can say yes, a permutation can be formed and the output is yes. Let us look at another example, no case. When will we get the no case? So here n is 5 as well. And we have an array A which is 2, 4, 3, 4, 2. And this is supposed to be B array and we are supposed to construct C array. Again we'll do the same thing here what we did earlier. So if my array C is supposed to be a permutation of n, it should have all the elements from 1 to 5. 2 is currently not present in my array C, I'll just add 0 and I'll take 2. 4 is currently not present in my array C, so I'll add 0 again, I'll take 4. 3 is currently not present, so I add 0, I'll take 3. Now I have 2, 4, 3, right? So I need 1 and 5. I need 1 and 5 to have permutation. So I have 4 here. Now if I add 0, I will just get 4 here, which does not help me because 4 is already present. So I need 1 and 5, right? Now I can't get 1 because I cannot subtract values here. My array B should have only positive integers. So I can't subtract, I can put negative values here. So I cannot get 1 and I can get only 5. So if I add 1 here, get 5. What about the last case? So now I have all the elements from 2 to 5, I have to get 1 and there's no way for me to get 1, right? From 2 I can only get 2, 3, 4 and 5. I cannot get 1 here because to get 1 I have to subtract and I cannot have negative elements. So this is not possible. Permutation is not possible. That's why we output here no. So what should be the logic to solve the problem? One thing is clear, right? So from each element we can get only these elements, we cannot get the previous elements. So to solve this problem, what I will do here is, first I will sort the array. After sorting, my array will look something like this: 2, 2, 3 and 4, 4. Right. Now I will start my permutation from 1 to 5. So first I will try to take 1. I will try to take 1. Now, how can I take 1? If you look at the first element itself is 2. The first element itself is 2. So this is the minimum element present in my array right now because my array is sorted. And the minimum element itself is 2. So I can only get from this 2 to 5. I cannot get 1. So here itself I can break and I can output that no, I cannot form an array. I cannot form a permutation of C in this way. I cannot form a permutation of C in this way. Right. So if you look at this first example which I've taken before, so let me sort the array 1, 2, 3. So this was 1, 1, 2, 3, 4. Again, I want the elements from 1 to 5. So how can I get 1 here? I'll add 0 just. I'm getting 1. How can I get 2 here? I'll add 1. I'm getting 2. How can I get 3 here? Add 1. I can get 3. How can I get 4? I'll add 1. I'll get 4. How can I get 5? I'll add 1. I'm getting 5. So I'm getting all the elements from 1 to 5. So I can say yes, that I can form a permutation. So this is the simple logic, guys. We'll sort the array and we'll just check whether we can get these elements or not. So let's proceed with the code. So in input we are given input format where first line is n, next we are given n array elements. So let's quickly take this array as input. Right. So my next step was to sort the array, right? So I'll do that. Now after sorting the array, I'm just again iterating over the array elements and I'm checking whether I can get the elements from range 1 to n. 1 to n. And I also mention a boolean variable here which will be, by default it will be true. Now how can I check whether I can get elements from 1 to n? If my current element a of I is less than or equals to I plus 1, right? If this is the case, then I can get that element. If my current element is lesser than the element I can want, then I can add 0, 1 or 3, however value can in my B array to get that element. If my current element is greater than the element I want, then I can get the previous value, right? Because I cannot add negative numbers. So if this is the case, that is true. So I will look for reverse case here. That is, if my current element is greater than the element which I want, then break. I'll just break. And in the end, I'll just check my flag variable. This is true itself, then I'll print yes. Else I'll print no. Let's see if this will work. try to submit this as well. Yes, it's working. Cool guys, let's move on to our next problem then. So trick or treat is our next problem. Let's read the problem statement. Halloween is approaching and you plan to distribute sweets to children visiting your house. You expect a total of M children. You have N box of candies, of chocolates. The ith candy box contains EI candies and the ith chocolate box contains B chocolates. Your task is to choose exactly one box of candies and one box of chocolates. You mix them and distribute equally among M children such that no sweet is left. Count the number of ways to choose one box of candy and one box of chocolates to distribute sweets evenly among M children. So, in the problem statement, first of all, we are given two things, N and M. What is N here? N is the size of number of boxes of candies we have. So we have N boxes of candies and as well we have N boxes of chocolates. So these are the things that are given to us as input. N is the size of the number of candies we have and number of chocolates we have. So each of this is a box. Each of this is a box and we have N boxes of candies and similarly for chocolates as well we have N boxes of chocolates. And what is M? M is the number of children. N is the number of children. And what we have to do here is choose one box of candy from candies, choose one box from chocolates, add them up together and distribute among M children such that each of children get equal amount of candies. We have to distribute the candies plus chocolate box evenly. Right, so this is what we have to do, and in the output we have to print the number of ways we can do it. That is the number of ways we can select boxes such that the candies and chocolates can be distributed evenly among M children. So suppose we can select this box, or this box. So just the number of ways we can select the boxes. So let us look at the sample input for better understanding. So we have N equals to 4 and M equals to 5. We have 4 boxes of candies, 2, 8, 3, 10. So in the first box we have 2 candies, second box we have 8 candies, in the third box we have 3 candies, and in the fourth box we have 10 candies. And the next line contains the box of chocolates. So in the first box we have 5 chocolates, second box 12, third box 15, and the fourth box we have 13 chocolates. We have to distribute among 5 children. So what can we select? So suppose we select this box which has 2 candies. So we can group this with 13. 2 and 13, total is 15. And we can distribute 3 chocolates and candies to each child. We can do this. What else can we do? If we take 8, what can we group with? We can group this with 12. So 8 and 12, 20. We can distribute 4 chocolates and candies. 3. We can again group 3 with 12. Output is same as 15. And next, what else can we do? We can group, here we have 10. We can group 10 with 5 or 15, and as well we can group 10 with 15, right? The total will be 25. So we are a total of 1, 2, 3, 4, 5 ways we can select boxes such that we can distribute the candies evenly. So hence the output here is 5. So I hope the question is clear to everyone. Let's proceed with the logic how to solve this problem. So one thing is clear, right? To distribute candies among m kids, however many candies we are getting, that should be a multiple of this m, right? If this value is divisible by this m, only then we can distribute candies evenly, or else we cannot. So this is now what I have to check. I have to select two numbers from these two arrays such that its value is divisible by m. Its value is divisible by m. Let me start again. Now, how do we find that? How do we find that value? So we have 2 here, right? So how do we select how many numbers in this array I can add up with such that its value is divisible by 5? I mean, one thing I can do is, of course, I can just for each value iterate over the entire array, add 5 plus 2, check if it is divisible by 5. It's not divisible, check 212, it's not divisible. 215, it's not divisible. 213, yes, it's divisible. So I will increase my answer count by 1. You can do this, but I have to do this for every element, right? So for every element in candies, I'm searching the entire array again. So overall complexity will come out to be n into n, and according to our given constraints, n squared solution will not pass all the cases. Hence, you have to come up with a better and optimized solution. How can we find how many numbers I can group this 2 with such that it's divisible by 5? I mean, in here I can see that if I group with 13, it's divisible by 5, right? So how can I get this information? So for this, what I will try to do here is, I will not store the values directly. So here for 2, if I just add 3, it's divisible by 5. If I just add 3, it's divisible by 5, right? So I want to get this information. Do we have any 3 here? Do we have any 3? So for that reason, what I will do here is I will first of all store the mod values of each of these elements. So for 2 mod 5 is 2 itself. So for each of these elements, I am storing the mod value with m. So 2 mod 5 is 2 itself. 8 mod 5 is 3. Right? This is I am storing the odd numbers that are left out. Odd numbers that are being left out. So 3, and in here the value is 0. In here the value of 0. Now what does this mean? Now first of all, let's do that for the second case as well. So 5, the left out value is 0, 2, 0 and 3. And 3. So I have now I'll again check. I have 2 here. Now I want to group this with 3, right? I want to group this with 3, and I have 3 here. Now how to get this information efficiently? I can just use simply a map, and I'll just store these values here. Key as my value, and its frequency will be the value in my hash map. So currently 3 is occurring only one time, so its frequency will be 1 itself, right? So next element is 3. So 3, I can group this with 2 itself, right? And I'll get this value from hashmap itself. I'll check if 2 is present or not. If 2 is present or not. If 2 is present, then I'll group them with this. Again for 3, I'll check with this itself. And for 0, what should I check? 0 itself. I'll check if there exist any zeros in my array. Yes, then I'll group them this way. So let us quickly draw out the complete solution. So I have 2 zeros, I have 1 2, and I have 1 3. For 2 to be divisible by number 5, I need to add 3 more value. So I'm just basically doing 5 minus 2, 3. I need 3. And I'll search in map. Yes, I have 3. So I'll increment the count by 1. So my count is 1 currently. Now for 3, 5 minus 3 will now give me 2. So I need 2 here. Yes, I have 2 as well. So now my count will be currently 2. For this 3 as well, I need 2. I have 2, so my count will be 3. For this 0, I need another 0. I have 2 zeros here, right? So I can group them with both the zeros. So I will increment my count by 2 this time. So my count in total will be 5, and that is what is the output. We have to print 5. So this is the logic. Let us proceed with the code. So let's see the input format. We are given n and m. And then we given n boxes of candies and n boxes of chocolates. I'll initialize array A for candies and array B for chocolates. And we'll quickly take these values as input. Fine, we have taken all the values of A and B. Now what have we do? We are using a hash map, right, to store the values. So I'll initialize that as well. Our key and value both will be of integer type. Yes, next what are we doing? If you observe, we were just storing the mod values, right? We were just storing the mod values in both of the arrays. So I'll do exactly that here as well. So instead of putting into the array directly, I'll take that value in a variable, and in A of I will put v mod m. And in my hash map, I will put, first of all, my B array will be B of I mod m as well. Fine, I'm filling up my hash map as well with B values, mod m B values. Now this is done as well. Now my next step, what do you have to do? I will iterate over my chocolate array A. I will get this element A of I, right? Now, for any a of I, what element do I require to pair up with such that that element is divisible by m? I will get that information by m minus a of I. So m minus a of I is any number I require extra for it to be divisible. So if my first element is 2 and m is 5, 5 minus 2, I need 3 more elements for it to be divisible by 5. So this is how I'm getting this information. Now I will simply check if this value is present in my hash map or not. This is present, then I will increment my answer. So for that I will also have to initialize my answer variable. And by what value will I initialize? Its frequency. So however many 3's I have in my array, I will increment my answer by those many count. This will be answer, right? Yes. Now, one additional thing that I need to take care of here is, suppose the value I'm getting here is 4, value I'm getting here is 0, right? So if I do m minus 0, I'll get m. And if you see, I have no m here, I have 0 itself. So for 0 case, I'll just handle separately. For 0 case, I'll just handle separately that if my a of I is 0 and my hash map as well contains key 0, then I will increment my answer by same hm dot get 0. Else if I'll do this. Now at the end, I'll simply print the answer. Let's see if this will work. Y and 0, let's try to submit this. Yes, it's working. Cool guys, I hope everyone is clear with this solution. Let's proceed with the next. Split permutation is our next problem. Let's read the problem statement. Here the goodness of a permutation is the maximum integer k such that a permutation can be split into exactly k subarrays where each subarray has the same sum. Here given an integer n, generate a permutation of length n which has the maximum goodness. So in the question we are provided with an input integer n. What is n? So we have to generate a permutation of n. We have to generate a permutation of n. So let us suppose n is 5. So 1, 2, 3, 4, 5. This is a permutation of n. This is fine, but additional thing is mentioned here. The goodness of a permutation is the maximum integer k such that the permutation can be split into exactly k subarrays where each subarray has the same sum. So it is mentioned that the goodness of the permutation is the maximum subarray we can split this permutation in such that each subarray has equal sum. So how can we split this permutation such that the subarray has equal sum? So I can group these 3 together, but this subarray does not have 3 sum. And what else can I do then? So I can group this 5 and together. I can group 1 and 4 together, the sum is 5, and I can group these two together, right? So this subarray has sum as 5, right? 5. So each subarray in this permutation has sum 5. So I can split them into like this, which is 5, 1 and 4, 2 and 3. Now, what I have to do here is I must try to split the subarrays into maximum possible subarrays. I must try to split this permutation into the maximum possible subarrays as possible. So in this case, the k is 3. Since we are splitting the subarray, splitting the array into k, 3 parts. This one part, this is one part, and this is one part. So k here is 3. We have to maximize this k. We have to maximize this k, which has the maximum goodness. So this is what we mean by a goodness of a permutation. Here k is the goodness of a permutation, and we have to maximize this k value, right? Can we maximize this k value anymore? That means maximize means we have to split it in more than 3 parts, right? Can we split it into 4 parts? No, we cannot. If we split it into 4 parts, we cannot have a subarray such that all the subarrays have equal sum. So 3 suppose is looking as a maximum here. So I will output as 3 for this n equals to 5 case. So this is the question. I hope the question is clear to everyone. Let's proceed with the logic. Yes guys, so how should I go on about to solve this problem? As usual, we'll look at the input cases to understand better. So for 1, the output is 1 itself. We cannot split it more than 1. We have only one element. For 2, this is a permutation. So the maximum ways we can split is 2 itself, right? So for any n, the maximum ways we can split the permutation in is n, and the minimum value is 1. So since I want my key to be as max as possible, I will start with max. Can I split this array? Can I split this permutation into size 2 such that each subarray has equal sum? That means 1 and 2. No, right? I cannot split each individual element. They do not have same sum. So next I will check with 1 here. So if I just group them all together, that would be a valid answer as well. So sum is 3 and k is 1. So the output here is for 2, and we have to print this value. That is the permutation that we have found. So I'm printing 1, 2. Now let us take n equals to 3. So 1, 2, 3. This is the permutation we have. Can I split this into 3 parts? 1, 2, 3. No, I cannot split this into 3 parts. Can I split this into 2 parts? Yes, I definitely can split them into 2 parts. Each subarray has 3 sum here. So this is a valid answer, and I'm outputting this itself. 1, 2 and 3. So let me draw out some more examples to better understand the logic. So we have done for 2 and 3. 1, 2, 3, 4. I think these many examples are enough. Now remember guys, I want to split this permutation into maximum subarrays as possible, right? So I'll try with that first. Now if I want to split them into maximum subarrays as possible, maximum is n, minimum is 1. I'll start with 1. Whether I can split them, this is 4. Can I split them into 4? Obviously not. So I'll then now lesser value, I'll try to group them, group my elements. So 4 I can pair up with 1, and 2 and 3 I can pair up them together. So my subarray would be then 1, 4, 2, 3. 2, 3, and 1, 4, this is as well valid. You can print any of these two values. Now let us look at the next case. We'll group this together. I will group this together, and I will group this together. Each subarray has 5 as their sum. Now let us look at the next case. I will group this one separately, group this together. No, this is not working, right? We cannot split in this way. So I'm grouping them together. I'm grouping this together. I'm grouping this together. For the next value, I'm grouping this together. I'm grouping this together. I'm grouping this together, and I'm grouping this together. So what do you observe here? What do you observe here? So for even length n equals to 4, I'm grouping up in this way, right? I'm decreasing my values one by one. For 4, I'm grouping up first and last, and then second last and second element from the first. For 6 as well, first and last, then 2 and 5, and then 3 and 4. But for odd elements, what I'm doing, I'm grouping this last element separately, last element separately, and the rest will be the same. So 4 with 1, 2 with 3, 6 with 1, 5 with 2, 3 with 4. So this is the pattern here. This is the pattern. You just have to find this pattern and print these values. But this will be the maximum amount of subarrays we can split my permutation in. So if everyone is clear with the logic, let's proceed with the solution for this. So let's proceed with the code here. So in the input, we just given n, and for the solution, what we are doing, we're just checking if given n is odd or even. If it is odd, what are we doing? We are just printing the last element separately and then grouping up them together the rest. So for that, I will initialize two elements. One that will start from beginning, j will start from the end. So if this is odd, I will just print my j element separately, and rest I will group them together. And so till where I should print? Well, I is less than j. So while this condition is true, just printing I, incrementing its value, printing j, decrementing its value. That's it. Else, if it is even, I will do exactly this, just that I will not print this value, right? So after this, I will print a new line. Let's see if this will work. This is working. Let's try to submit this as well. And even the output, the third output here is different, it doesn't matter because this subarray is valid. So 3, it can be split in this way. We just have to print any permutation that is valid. Staying all the time. It's just passing all the cases. So that's it for this video, guys. Hope this video was beneficial for you. If so, please do share it with your friends, and don't forget to like, share, and subscribe to the Smart Natives channel. See you next time. Till then, bye bye.